Hello, people. Hope everyone's doing okay. Did water just explode out of my water bottle? I think so. How's everyone doing? I think for the first time in a bit, I don't have anything to share. Maybe. I guess I'll talk about, well, the Asida is sort of in pieces at the moment. Not in pieces, but I figured out the problem. If you watched the Asida stream, I was still having some problems with no audio after we did the RVLDD, upgrade, I suppose. There was no audio, and I was getting random freezing during the RVL menu. Now, I fixed both. I think I fixed both. I haven't given them extensive testing, but the audio, I believe, was just I needed to resolder the audio flex, the audio kit lines of the four bottom-most vias. So I kind of did a once-over to everything, and that seemed to fix that. I did also, what else did I do? I guess I didn't do anything else. Then the freezing was apparently that can happen if the I2C lines, so the SCA and SDA, or SCW and SDW, from the flex, they kind of like, there's these breakout points on the right side of the RVLDD flex. I routed those wires as far away as possible from the other. I guess I'll show you. If you're watching this and you're curious, I'll just throw it up on the thing here. So this is in the 4-layer tech Discord. So here, the SDW and SCW lines, I had them go to the right this way and like alongside the right side of everything, and then like around the front, as opposed to going with all these other wires on the left. So this, I think, solved the random freezing for the Asida. So it's still not 100% altogether because I'm not happy with this. And this is a flaw, I think, with the design of the controller board, but because it's they should give you other options for how to route, or like, this is pretty much right. This is the right controller stick, or is it right? I don't know, one side or whatever, but it runs right into where the screws need to screw the bracket that keeps the screen into the screw post. So I don't understand why they didn't route this above it, like, or like away from the screws here, because as you can see, it's pretty easy to get this controller board, which is right above it here, to hit that screw. And I even put Captain Tape in my video, but it's kind of a mixture of two different things. One, like I was saying, the controller board could be routed a little bit differently so that it is nowhere near that screw to give you optimal, any screw choice that you want to. But two, I think the plastic on this particular revision of the bracket that holds the screen, Wesk made this specifically for the RVLDD, and actually he mentioned that he made an update. He made a version 2, which has those pieces of plastic are thinner. It's like there's little tabs that kind of are in the back there. He made those a little bit thinner. So that, in combination with countersunk screws, so I actually ordered some M2 countersunk, which is like the V shape, so it has a flat top. Countersunk coarse thread screws from AliExpress, so those are going to come sometime. I ordered like 4mm, 5mm, 6mm, because I'm not sure how thick, tall they need to be. And I'm going to redo this so that basically the screw is going to be countersunk, so that even if it does interfere with the board, it's not going to like flex that controller board that much. So that should solve that. So I'm going to revisit the Asida in a little bit. I'm kind of taking an Asida break, well, obviously from the title of the video. Looks like you could use a countersunk flat top screw. Yes, that's what maybe you might be behind when I just said that. So yeah, I did order some flat top screws, the countersunk one. So, and Wesk's design now, that mount is countersunk, so it allows for countersunk screws, which is good. I think it's I don't love, it could have been solved by just having I guess I can show you guys what I'm talking about. It's in a box right now, so I don't lose anything. But I'll show you just for a half a second. God, help if I turn the camera on. Okay, so this is what I was talking about. So here's the controller PCB, okay, the one with the C stick, and underneath of it, none of it is screwed in anymore. You could barely see the screw here, okay. There's no reason that they couldn't route this PCB over here, right? Like, I mean, I guess it does sort of get in the way of the C stick, but they could have made a curved PCB to put that board here instead. Yeah, that would have been ideal. Or, worst case scenario, have this be another board that screws into the back of this or something. So you wouldn't have, then you could use any screw. Because I do like these other screws, these hex head, well, you can't see them, but I use them pretty much everywhere else. There's like these hex head, coarse threaded M2 screws. I really like them a lot. Like they offer a good bite into the resin shell. So anyways, that's what I would have liked to use everywhere. But it is what it is. So, or use a drill bit and make your own countersunk hole. Yeah, I could have done that. I actually do have countersunk bits that would do that. I sent that just as you start to. Oh, okay. That looks like all my products just in separate boxes. I'll get to it later. I try not to because they end up sitting in boxes on my bed, and then that gets annoying at the end of the night. I actually haven't slept in this bed in a bit. It's kind of a long story, but I would like to sleep in my own bed again sometime because I sleep better by myself. But we won't go there tonight. Not in a bad way. It's just that's sort of a debate. Not for now. Okay, so I'll stop talking about that. But we are going to talk about PCBWay and this topic, which I'm super excited about because I was using this ATI VGA card, right? So I was testing it with this. I just like it that it's an ATI card. It's like, even though it was like, it's not very period correct for any of my retro computers. It's like 1989, I think is the date code on this. So it's very new compared to all the computers that would have been good for. They're kind of older. It's older than, or newer than that. But I was able to put the front of the Micro 8088 on because I took that card out. So that's where we're going to be sort of filling out most of the rest of these. Don't worry about this wire. That's that's going to go away eventually. Not tonight, but so we've got 3 more cards to put in here. So I've got I'll give you an update on. If it wasn't clear, yeah, this video and basically this series is sponsored by PCBWay. So I'll give you an update on where we're at with the Micro 8088. If you don't know, it is a clone IBM XT, which is the second Intel or the second IBM PC. It's not the IBM PC, but the IBM XT, which is like the middle child. We've got so far the backplane and the CPU board, which is the top, or this one here. We've got a floppy controller with a serial port back here. Here we have the XT-CF Lite, which I actually got a machine metal bracket for it on eBay. I also got the VGA bracket from Mauser. So there's a specific VGA generic kind of one. That was for the serial port, so it's the same as the serial port there. So I'm trying. My wife hates my comforter, so it's only on half the king bed with its roll up on the middle. It creates a nice get off my side barrier. Yeah. We have a queen bed in the other room. It's not quite big enough, so yep. So I'm rushing to try to get this finished before Retro World, which is this month, later this month, in a few weeks actually. So what's left to be done? Obviously all the PCBs that we're going to talk about in a minute. But I also, and I'm sorry PCBWay, I ordered the front panel. So if you look here, there's actually front panel buttons here. So there's power and reset, and there's actually LED and hard drive activity lights there. That's a separate PCB. That is a button PCB in the front there. It has like a sort of like modern-ish computer style, you know. I can't really point to it right now. having problems pointing to it in here to the whatever. I'm backwards trying to point to it. Whatever. It's in the front there. You can kind of see the front of it. The design for that PCB was on OshPark. The only way for me to get PCBWay to make it would be if I imported the project into KiCad and then remade the Gerbers, because the Gerbers were not in the on the page. So I'm sorry, I was lazy. So that's the only PCB in this project that was not made by PCBWay. But I just figured that's another piece that I have already. And the wiring that you're kind of seeing is just this generic. Back when I actually was into Bitcoin mining or Ethereum mining, I had this mining computer that I just had these power and reset and activity LEDs. It's just a little breakout thing that you can plug into a motherboard to turn the computer on and off if you want to without having to need a case. So I just have this wired up to various places. So like it's the hard drive activity LEDs here. The reset button is over here, and then there's like a power, or maybe that's I don't know. There's more in the back there. So I have the DuPont crimp stuff. I think I have a DuPont crimper. I'm not doing this all tonight. I'm just telling you this, like all the stuff that's left to do besides the PCB. I also have a piece of acrylic that I got on Amazon. So eventually I have to, I don't know why it's all black and nasty on this side. Ugh, I don't know what that's from. That's something in my house. So I have this piece of acrylic that has this cardboard on it still, or this sticker. So I have to, maybe my dad can help me. He's got a table saw. I can have him dimension it, and then it'd be pretty easy just to hold this over these spots where the screws go, and then just use a drill to make drill marks. And I can countersink those too, because I have that countersink bit. And then I can have a clear side panel, which I think would be cool. I mean, pretty modern, but I think it'd be a cool touch, you know, because it is a modern computer, I suppose. And then I have to reprint. I was not lucky enough to find an ABS color that I thought matched the IBM color scheme, the case color scheme, well enough. If you watched my streams in the past, you know I tried a couple times already. So I have this. This was a Bamboo Labs like tan color that looks like it's more like a caramel. The color on my camera does not do it justice. It's like, I don't know, baby poop or something. It's just a weird color. I don't like it at all. But then I also got a natural ABS, which has no color in it, and it's like translucent, weirdly translucent, and I don't like that either. So you can see the screw bosses through it. So it is pretty transparent. So that was a fail too. I couldn't really find a good. There's this website, Filament Librarian or something, where they catalog different colors. The thing that website doesn't really give you though is how transparent or not, and like the text, like filaments can be different textures and things too. So it's like, you know, I don't know. Gives you the color code, so you can look up a filament by its color code, but that doesn't guarantee you that it's going to color match whatever you're trying to do. So, hey Belmont, how you doing? All right. Thanks PCBWay for sponsoring this video. Let's dive into, let's open the boxes. The box here, I guess, the one box. I always cheat. I know, sorry PCBWay, they want me to open the box on the stream, but I've already opened them because I had to take a thumbnail. So I took a thumbnail of these are the ones that we're going to populate today. But this is how it comes, right? So they nice foam packaging, usually they over package it pretty much, which is nice. They're always in these vacuum sealed bubble wrap things. Did I get any goodies? I can't remember. Oh yeah, I got these stickers to add to my sticker collection. If I ever get a new laptop in the future, I save all these stickers so that I can sticker bomb it. But no pens this time. So this is the PCBs that we're going to be working on. I guess I'll just shout out their website too, because they like me to do that. So if you're curious how I ordered these, there's links in the description to all the repositories for these 3 boards. We'll talk about what the boards are in a second, but they'll always be the same. You'll always use the same method to upload the files. And if I have one gripe, I suppose. Oh, hey, JD Silva. Box time. Yes, box time. So it's always a tiny bit confusing to find where you have to go to upload Gerbers, which I guess is my one complaint about PCBWay. Not like they have to do anything, but PCBWay, I would appreciate it, like a nice, like, go to the quick order PCB button here, like have it like display on the front page. So you really need to go to Instant Quote here. Then there's this little under Calculate here, there's a little button that says Quick Order PCB. That's where you have to go to upload the Gerber file. So you click Add a Gerber file here, and you can upload the zip file that's in any of the repositories below. And for the sake of this project, I chose, I didn't change anything except for the colors, right? So these are all blue PCBs, just because IBM has been historically blue. I don't know. That's just the thing I wanted to do with the white silk screen. I did end up doing edge connectors on all of these boards, or most of them when I remembered. And so I click edge connector here. I hope you guys can see this. Let me make it a little bit bigger maybe. So edge connector, I click yes, and then beveling yes, and I think ISA is at 45-degree angles. Now technically, well, their website kind of blows up when you make it bigger. Technically, the best thing to do for these cards would be to do them in hard gold, because that is the most durable. That's like when you get a professional edge connector card, like any graphics card you get, or anything that you would buy, like an expansion card or whatever, should be hard gold, pretty much, because that gives you the longest longevity, most insertions, I mean. But what I did was I just did ENIG or immersion gold on the whole thing. So the surface finish on everything, including like the pads and things, is ENIG, along with the edge connector. Now, the cheapest thing is Hassel, which is just the lead. Actually, it might not let you do that if you select. Oh, you have to select not ENIG up here. So if you select Hassel for the edge connector, then you can have your surface finish for the whole board be Hassel. The problem with Hassel is eventually you're going to wear out the lead. And that's actually the problem that I had with the Bug Tendo, was that eventually its cart edge for where you connect the 72-pin connector for the cart slot, eventually that's going to wear out, and it will no longer, either due to corrosion, there could get, as soon as you get any surface imperfections, bumps and stuff, then it is not going to, it just decreases it just increases the failure rate, I suppose, right? So even if you were to go back over it with more lead, by making those fingers different sizes or whatever, you decrease the likelihood that that thing is going to work again. Not that ENIG is going to last forever, but at least there's a thin layer of gold. It's not this hard gold, I suppose. But anyways, all right, enough talking about that. That's really the only settings that I changed. So these are immersion gold. I'm fortunate enough that that does add to the price versus Hassel, but I'm fortunate that I have PCBWay sponsorship that helps me out with that. And I've been very happy with all the boards for this project. Okay, how many times do you need to reinsert your cards in this? Just never, basically never. So yeah, you're right. That's a good call. So like once you have this thing built, I mean, it does save you a bit of money. So if this is going to be a display piece or something, but for the amount of time and money that you're going to spend on other parts anyways, I mean, I don't know. That's up to you to make a judgment about whether or not you care about that. But for some of these cards, right, like the XT CF card, you could use that in other builds, right? You can use that in other to test other projects. Same thing with the VGA card. Like if you don't have a VGA card and you want to build one of these, something like that, you could easily test other retro PCs, right? So that might be a thing that you would pull out once in a while. But for everything else, probably not. They're pretty bespoke to this. So maybe the sound card too, but yeah. Okay, let's get to Basically, we're going to try to focus on the... I don't have all the parts yet, unfortunately. Just the timing of things. I had to split... Oh, I guess I'm going to I hate to gripe on this project because it's a really awesome project, but the most annoying part about trying to build a Micro 8088 is the BOM. So I'm going to try to micro gripe about that. And I'll just use specifically the... Gotta turn my AC up because it's hot AF. I'll micro gripe about the... did I just make a new term? Micro gripe? About the VGA. I don't think there's a single one of these projects that has a good BOM. And what I mean by good BOM is like somebody coming by and maintaining... Because some of these projects are some of the parts of... So, okay. Each of the PCBs in this build is in its own GitHub repository, which is fine, right? That's how it should be, so that they, if they need to make updates or something, they can to each individual part, and it's just kind of self-contained. But the problem is the BOM. So there's a bill of materials, and this is what you would need to buy all the remaining stuff to populate a board, right? So you need the Gerbers to make the PCB, and then you need all the parts. The problem is, well, the good news is, it tells you where to get everything, right? So it does say, these couple of parts at the top, like the memory and this EEPROM, like it specifies a specific EEPROM, as well as the chips, the VGA chipset. So like this card is based off of a giant chip, which I have. I do have that, so that's probably going to be the main focus of this build. I don't have the memory yet, but I'm hoping that this works. So I don't think this was not pulled off of another board. I think this is a new old stock. But it is a Trident VGA chip, right? Big one. The problem is all the other stuff, because what you're supposed to do is you're supposed to download the BOM. So I know people want me to dive right into building it. Well, maybe not. Maybe some people might think that it's the most boring part. But let me see. Is there a BOM I could just... Is there a downloadable BOM in here? I'm trying to provide value here, guys. Gerber. Is it in the Gerber? No. KiCad? Nope. You probably could produce it if you import that into KiCad. So this is a pretty bad example because, actually, let me just keep looking. Is there a BOM? No, I don't see it. Well, anyways, so there's no already downloaded BOM. I guess what you could do is you probably could highlight this and copy it to an Excel spreadsheet. All right, we'll do it for you guys, for ha-has. We'll see what happens. All right, so I have. Oh, I don't even have it installed. I had OpenOffice or LibreOffice installed. All right, let's go to Google Drive. Make a new sheet. And we'll copy that table into a new thing. Wait, let's get rid of the formatting. Okay. Even this is not great. Well, anyways, you get the idea that the BOM. So let's just say, for the sake of argument, let's say you were able to massage these values so that they were just the part number, right, and not the Mauser part. Some of these have gone out of stock, are no longer being made, right? So the upside is that the values are there and they still provided the original part number, but it's up to you to find an equivalent part. How many times do you... Oh, I always have to remember to not talk about bill of materials while I'm on a plane. Why? Oh, is that a weird bad plane pun thing? That's funny. So, anyways, I had to find some of these parts manually. Let's see if I can remember which ones were kind of out of stock. I think maybe these capacitors might have been. I don't remember. Let's see if we can find a different project that actually had the BOM listed separately. Okay. Micro, sorry. Just trying to show you what I'm talking about, and I'll show you my strategy for getting, for choosing other components. So I'm trying to find one. Maybe it was the sound card. Oh, hey Cooper. Don't talk about bombs. Oh, yeah, bombs. You can say bill of materials, but not bomb. Got it. Does this one have a downloadable bill of materials? No, it doesn't. Well, so that's part of the problem. But so let's see. Can I pick one of these? I'm just gonna try this first one, and if this one works. Okay, so it says it's from Mouser. So let's go to Mouser. And basically you're going to take the second half of that part number and slap it in the top here. Okay, perfect. Perfect, non-stock. So the top option is no longer in stock, okay? So, depending on what the part is, the easiest way that I found to find replacements is to do this. So you go down on the bottom. So thankfully, you know, Mouser is set up in a cool way where you can go down to the specifications list on the left here, right? And so we're going to check certain parts of it to find an alternative that's similar. So first of all, we want radial because that's the style of capacitor that this is, right? So you could do the same thing with resistors or whatever, buttons or something, parts. So it's 10 microfarad. It's 10% tolerance. Dielectric X5R, sure. You can even put the lead spacing 5 millimeters. Don't know if the voltage DC, but we could slap that in there. Now at the very bottom here, it shows similar. Found one other similar one. Is this in stock? Okay, perfect. So with all those options, actually this is a similar part that is in stock at least. So at least you can order it for now. So that's my strategy going through the list is like if it becomes out of stock or it's out of stock when you put it in there, you go to the bottom and type in the specifications and it will recommend you alternatives. So that's what I had to do for the whole thing. So yeah. All right, so like I said, I don't have everything. I had to split this up, but actually between some things Mouser had no alternatives or DigiKey might have the exact thing that Mouser no longer stocks. So I split it up between Mouser and DigiKey depending on who had it in stock. And I also am waiting for some memory from eBay. So we have some other things though. And we could try to install this. This is probably the meat and potatoes of this whole build. But let's get the computer out. Not the whole build, but this card, the VGA card. So let's solder that. That should be fun. Okay, fun. Let's, oh boy. Sometime my camera goes derp. Sometimes the camera go derp. It's still going derp. Gotta unplug it, I guess. Oh. If you see any tweets lately, you will know that I mentioned I wanted to start making YouTube videos again. Oh, you gotta be kidding. All right, I need to unplug a thing and plug it back in. So, I might do that. I might switch. I probably would have to switch. I don't think I'd be able to maintain both streaming, at least in the beginning. Come on, work, Camlink. Did that work? Okay, great. Okay, whew. Yeah, so I might stop streaming in the potential coming future. But I don't know. I guess I want your guys' feedback. The first video that I'm thinking of making is going to be about options for original Xbox wireless controllers. So if you know, I got the BRX adapter I have. I also do have a Xbox Hunter controller. And I ordered the OGX Mini from, I can't remember the person that made that project, but Wired Opposite. And I'm gonna basically do a comparison because that's a smaller OGX 360 T4. Hey Vincent, my biggest problem with the build was the chicken or the egg part. I had no other 8-bit cards to test stuff with. Yeah, right. It helps to have known working at least one card. Yeah, and that even if you do end up ever going to trying to collect vintage IBM stuff, having other cards that you can actually diagnose issues is really helpful. Like this is now a VGA card that will work with an IBM PC. So, you know, that's why I pointed out that Enig, you know, it's not perfect, but I think it is a little bit better than Hassel as far as the durability of this thing. Okay, so that's my first video idea. So to gear up for that though, it's not like I can start working on it now. I've already worked on not a script per se, but just notes about what I'm going to say. But I also want to do lag tests on all those controllers, or at least do the best that I can to lag test all the different controllers. So I've actually ordered the parts to be able to do Mr. wireless controller testing. So that is going to be a kind of a nightmare with an Xbox controller because Xbox controllers, like there's no snack adapter for Xbox. There is, somebody has made an Xbox connector, like female or male, and I guess to USB, so that you could use an OEM Xbox controller and thus, you know, all the third-party controllers with a computer. And I'm hoping with Mr. So with Mr, you can get an Arduino, and you have to set up this special NES core, and you have to wire a whole bunch of stuff, and you actually have to solder a wire into the controller. I'm hoping to be able to lag test, you know, an OEM Xbox controller, which should be pretty low latency. The Retro Fighters Hunter, I want to lag test that, wireless, you know, 2.4 gigahertz. And an Xbox Series controller through the OGX Mini adapter using the 8-bit DO adapter, so that lag test that, and then the BRX adapter. So I should be able to accomplish all of that with that simple setup, but I want to have all that stuff in. So I might stream setting up a lag testing build, but I'll use that data in that first video, which is, you know, are these wireless controllers any good? These old, yeah, I don't think they're still made, but they're new old stock, I think. Am I building it? No, actually, I think it's cheaper just to buy one from Wired Opposite. So if Wired Opposite ever stops making them, then you have no choice. But for now, I don't think you could get a, you know, it's a little tiny Raspberry Pi Pico. It's like a special kind of Raspberry Pi Pico, like a compact one, and this like interposer board that Wired Opposite designed, and a little USB. So it lets you plug in a USB connector into an Xbox, and a little tiny stubby USB-C to USB Type A wire, all in a bundle for $15. I don't think you could beat that. I don't think you can actually build your own for cheaper than that. There's no way that you'd be able to order the PCB and the components for I mean, there's only a few, and then you have to buy the little Raspberry Pi Pico, and you have to buy the little USB cable, and you have to order the other. It's just a lot. Just so, anyways, for now, it's simpler just to order one from Wired Opposite. There is. I was going to also talk about Modsville. He made a compact, even more compact OGX Mini, but we'll talk. I'll talk about that during the thing. I want to support Wired Opposite because they were the one who built the firmware, because originally it was by Ryzy, made the OGX 360 firmware for a different microcontroller. So for is it an Arduino? Maybe. But then he ported that to the Teensy, but those versions are expensive. So anyway, so that's a long story. So I'll show you eventually. All right, I'll shut up and I want to solder this. All right, so But I want your feedback, right? If you guys have a topic you think I should cover, I'm just gonna pull over my microscope. I'm not gonna do retro modding news, unfortunately. There's a lot of reasons. I just don't have a workflow good enough to sustain doing it every week. Maybe some year I might come back and do it again, but I can't right now. So unfortunately I can't commit myself to doing the news, even though I think a lot of people would appreciate that. But I can commit to maybe making videos. Okay, let's solder this thing. Actually, I'm interested. Let's take a look at this actual trident without bending the any legs, hopefully. So I didn't even look at the, well, let's take a look at this. So which one did I order? Oh, I've got to turn off my overhead light. There we go. Okay, so this is the trident. Excuse me, why doesn't this work? It doesn't like this. Okay, TVGA 9000i. It does not love something. The focus. There we go. TVGA 9000i-3. That is the chip that I'm going to be soldering now. But while we're here, let's take a look at the underside of the legs. Is there any... I like your project streams. Maybe you could do a gaming stream a week or 2 weeks. Actually use the project. Yeah. You don't know, Alterations, how much I've thought about that. My true love really is to do the mods. Right? That's always been my thing, is really just to... I'm very interested in technology. I don't know, I'm not an electrical engineer by trade, but I hope people understand that I get enjoyment from mod work, right? It's not like I'm just a guy who wants to make money or something, or like has no interest in it. I really do. Since the beginning. That's the whole reason I made my channel, is because I was doing it anyways. I figured I basically felt guilty that I wasn't sharing. I'm not an expert, but I know how to follow instructions, and that there's some things that are not clear even for very beginners. So I know at least more than a beginner did, and so I just wanted to share, to make it easier for people new to the hobby. So, but with that being said, I would love for this to be my day job. I would absolutely love that, or get to a place where I could do this, even if this is not my day job, but like do something else that would allow me to work more on this, even if it wasn't for money. So yes, I do agree that I should play the games more. Okay, so I got to figure out how this is supposed to go. I guess I could cheat and just look up. I could just look it up. Are there any sort of hints? I guess there's this. There's this dot in this corner here. Is that indicating that it actually goes like this? Oh, let me zoom out here a little bit. So the quality of this chip is not bad. I don't really see any oxidation. It was not the same issue that I was having with that RGB amp for the Lava RGB. Yeah, I unfortunately, the soldering part of my YouTube videos actually gets the lowest amount of views in any video that I do. So unless I can find a way to jazz it up, like I think changing the camera angles like Macho Nacho does might do that. But there's more to it than that. So yeah. Okay, so I've got to figure out how this goes. I'm going to guess that is supposed to go like this. This indicator goes with this little guy here. But we can cheat and we can just look at the look at the picture on the site. Let's see, Super VGA. Hey, okay, great. So that is how it's supposed to go. So there's a dot here, in the bottom left. You guys probably can't see very well, but that goes to that corner there. But we can also tell by the text how the text is. His is super white. Mine is like, I hope this isn't like a fake chip or something. My font is like brown. I hope this isn't a fake chip. Okay, so it looks pretty easy to solder. But, so let's go ahead and turn on my soldering iron, first of all. Second of all, I'm going to get my good good flux out. I'm going to use my Amtech flux for this. Third, I am going to use a knife edge tip. I always get yelled at, like, why don't you do this? Why don't you drag solder? I don't know. People don't mind like that, but I'm going to try using a knife edge tip this time. And unfortunately, that means I have to turn off my my air conditioner. Okay, so first things first, we've always got to solder a corner. Tack it down. So I'm going to start up here, I suppose. This is too bright. There we go. Okay, so got that. This chip is exactly 30 years old. Yeah. 94. Neat. All right. That's crazy. I feel like I shouldn't. I suppose I should look at the spacing, because that leg looks a little bent. I need my okay, just a little bit. Just bend it over a little bit. Yeah, it's not quite there, but let's just make sure that all of them are not, none of the others are bent. Okay, they look all right. Yeah, okay, so it's just that one that I was about to solder. I need to fix it a little more. Just gonna do it off screen. Did I bend it too much? Let's see. I freaking did. Look at that, now it's bent too far out. Okay, good enough. Good enough, good enough. All right, so we need to keep our eyes on both the top. I know you guys can't really see. Trying to have it focus on the pins and not the chip. Okay. You basically need to focus at 3 places at the same time. So the row that you're on here, it's like you have to make sure that these pins are lined up correctly. But then you also have to make sure that these pins are lined up correctly. And I'm kind of pointing down here, the bottom row. Because if you have to do it all 3 ways. But the interesting part about that is you don't really have to nail it with the first pin, because that's the reason you do a 1 pin, is if you do need to fix it, you can still. So I'm not going to add any flux yet, I'm just going to send it. Okay. Okay, I think it's fine. Maybe a little low, actually. Okay, that's fine. Now, Actually, the other thing you could do is just carefully switch to the opposite side, opposite corner. And do the same thing. So basically that kind of forces everything to be lined up everywhere. So now we're just going to solder this pin down here. Oh gosh. Ah. So I should have added flux. All right, it's flux time. Okay, cool. So now that this corner is done, now you're pretty much safe all around to get started. Okay, so let's travel to, I don't know, a side we haven't soldered. So maybe the top, this is the top, but it's rotated sideways. So first things first is I'm going to add some flux. Okay, all the way along. Now, I'm going to add some solder, and we're going to try to drag solder. I'm going to do the best that we can to drag solder. So let's start down here. In the beginning, you don't really need that much solder. Just kind of, unless you do 1,000 of these, it's kind of hard to tell how much solder that you need on a specific part of a project. At least I have a hard time with that. Ah. Okay, see, that's the problem that you run into. I think I might have had way too much solder now. That's right. You can always get rid of it with a braid. Sometimes you get lucky and you can like move the solder around after the fact. Ooh, almost. Okay, so I have two big blobs that I got rid of. So that's okay. You can come back with your, I guess, three blobs. You don't want to really get rid of all of it because, obviously you still need some. Now we can come back and just add a little more flux. And hit it again. Hey, Ian Scott. What's up? Yeah, we're working on a VGA card using new old stock VGA chipset from Sergey Kiselev, the Micro 88 stuff. I haven't really been keeping up with what's good in the Pico space, not just the sound card, but the Pico mem too. I haven't even dove into that project yet. Seems pretty sick. Okay, so now that we're kind of getting to the end of this side, I like to always I feel like this kind of levels out the pins if you go in and then you sort of drag it out. And we can always come back. All right, that looks good. Maybe we can go to the opposite side then. But here, get some flux going. We got to try that other kind of, the 995 flux. Well, see, that was a good example of having the flux go with me, travel. Sometimes it does, sometimes it doesn't. I You know, I don't get a lot of opportunity to drag solder stuff, but so like it's a little bit like riding a bike, a little bit not. PCBWay project is doing great, perfect for 8088 computers. Yep. It probably could have consolidated like a lot of the boards that I built, but you know, it's cool that I like that it's, you know, it helps me to understand the computer better if I have all the little discrete parts, you know. But I do like the you know, the BIOS menu sort of feel of the PCBWay from the videos that I've seen. You can adjust stuff on the fly. Cool. Okay, I'm happy with that side. You still love the original hardware? Yeah. Well, you know, it's I don't know, like the more I get into retro PC stuff, the more I realize that I wish I was born actually in the 80s, because I was born in 1989. I was only alive for like a week in the 80s. It was so basically I'm pretty solidly a 90s kid, even though I was born in 89. But all the things that I'm fascinated with now, and basically like the foundational knowledge about computers that people have now, all stems from, you know, at least with PCs and stuff, it all stems from IBMs, and to some extent, you know, like Commodores and things, which I didn't have either. That was, you know, just right before my time. I had, you know, a Super Nintendo, but well, I did have an Atari, but I never had an NES. That was right before me. And then our first computer was a Pentium, so it kind of skipped a lot of that time. I mean, I guess still floppies and stuff, so it was still pre-CDs. Well, actually, no, that computer came, the Pentium PC had both a disk drive and a floppy drive. And for a very brief moment in time, actually, I saved my schoolwork on floppy disks. I remember having to hand in papers on floppy disk in middle school. So, but anyways, you know, I like to learn about stuff because I do feel like we're kind of in a, well, I don't know. It feels like it. Maybe it's not, but I feel like we're in sort of a retro computer renaissance in the same way now that, like, well, maybe the last 10 or so years, retro console stuff has been going through like a modding and resurgence phase. I hope that we'll see, I mean, I'm sure there's people who have already been dedicated to, you know, trying to kickstart this as well. But, you know, just the eras of retro computers, you know, it's kind of a little bit more difficult than, say, consoles, because it's a little more definitive to say, you know, this console is for this generation or whatever. But it's not as easy with PCs because there's so many, it moves so quickly. So, but it's really not that complicated. And so I'm thinking that it's kind of, you know, people are coming around to it. I know it's expensive, but I think that we'll start seeing, hopefully we'll start seeing reproduction parts, FPGAs maybe. I don't even know. Is Pentium FPGA possible? But stuff like that. That would be, that's kind of like my upcoming dream for people to have new old hardware. So they don't have to worry about compatibility. They don't have to worry about, you know, sourcing old parts or whatever and getting ripped off, maybe. Not ripped off, but because generally people have been pretty decent with prices, you know. But yeah, Still a lot of good stuff to be had, especially Pentium era. That's a good era. You still can get new old stock 3DFX chips. Started working on PC hardware around 1989 with a 286, 386. Yeah, so that's why I really enjoyed. I went back and I started collecting PCs. So I was just lucky that my parents or my dad had a IBM AT, which is the 286 IBM. If it wasn't for that, if I just had an IBM XT, I probably would have like, oh, maybe there isn't that much good here. But I really had to experience all the different eras, right? So I ended up buying a 3D6, and I actually have a 486 build, and I have a Pentium build, and I have a Pentium 2 build, and I think Pentium 2 and Pentium 3 were similar enough. But I think once you get to Pentium 4 and beyond, it sort of gets more like modern core, like the core architecture stuff. But your first family computer was a 286. Yeah, I think I must have used older computers, because I remember playing Mickey Goes to the Fair or something on a computer at the library, and I loved playing that game. But not the DOS version, because it wasn't exactly the same as the DOS version. I don't remember having to type in a password. So I don't know. Do they have an Amiga or something? I don't know what kind of computer they had at the library when I was growing up. Okay, so let's zoom in. We're going to check these pins to make sure that they are good. Now, how are we going to actually do this? I guess we could just do the wiggle test. So let's start at 1. $486 DX266. Yeah, I do have I think I have that pretty much same build of the VLB graphics. What's interesting is I tried to play Doom on a 486 66, and it's just not cutting it. I think I might have to use. Okay, so what I'm going to do now is I'm going to try to just wiggle all the pins. I need to clean this pretty good, but you can see if all these are good, have good attachment. Yeah, I think I'll have no problem with this chip because the leads did not have any corrosion. So I don't know if I'm going to check everything right now. I might do this off screen and just move on to the next thing. Well, I might clean it first, but yeah, I think these all look pretty good. Okay, neat. All right, so let's clean. It's got quite a bit of goop. There's my toothbrush. I just love DOS games since it doesn't involve Windows. Yeah, it's such an interesting. I mean, it's not as complicated as it seems. I mean, it kind of is, but the configuration of games might be, but actually using DOS is not really that difficult. DOS games are like console games, tiny operating system, and instant load. Yeah, pretty much. Yeah. Yep, no input lag, especially since around that time everybody was using CRTs anyways. So I remember playing Doom a lot. I played Doom a lot on our Doom 2. Actually, was the first one we got, but we got the Ultimate Doom, which was the bundle that had, I don't know, had a bundle of things on it. But yeah, that was my SimCity 2000. Actually, that game, I played a lot of that game, but I played it with no audio because we couldn't figure out how to configure the sound card properly. So for my entire childhood, that game had no audio, basically, because we didn't know how to configure it when we were younger. But now I know how to do it, which is interesting. Or I have compatible hardware for it now. It's just kind of funny. Neat. Okay, I think I'm pretty much done with the microscope. All the other stuff is, I don't necessarily know if you need a microscope per se to install that, but it does make it a lot more helpful to build this card for sure. So I don't know. You know, I don't know if they make. No, I don't know if anybody that makes a tiny VGA card. But yeah, it helps a lot. So I don't know if I'd recommend, you know, buying one just to do this, but it helps. Heretic Hexen, Original Descent, Mech Warrior 2. No, yeah, no audio. Because there were so many sound options for SimCity 2000 that we didn't know what we had. Because it was a pre-built gateway, you know. I'm sure it had some compatibility, but I didn't know how to configure the audio. I'm sure there was some, you know, whatever, the DMA or whatever, some settings that you had to know, which nowadays you could just Google it. But then, how old was I? I was probably like 7 or 8. So like I wasn't, you know, and my dad was not a computer person. You know, that was the reason he waited to buy a Pentium, because he didn't know. You know, he couldn't wrap his head around before that. Well, other than they use that IBM in his business. They actually I think they used it to control a CNC machine, or some kind of a bridge port or something. They used that IBM AT. Yeah, most DOS games run buttery smooth if you have the correct PC config. Unlike Windows, you need to brute force, because most games run at 30 FPS. And yeah, it's such a weird time now. You know, with all the technology that we have, you would think that we would have our shit together, like Microsoft and Windows and even the game publishers and stuff. But it's so brutal. Such a stagnant industry right now, I feel, in general. Okay, so next is, we can finally open a sack. I have a big sack. Hopefully my address is not on it. No, I don't think it is, but I got oh, that side might be. I got a big old sack of parts. And from Mauser. So I'm just gonna start digging. Now I hope that they, oh yeah, see, thankfully I put in the reference designator, I put what project it's for. So this is for the OPL. Oh, I guess I wanted to mention, and actually we can do a quick Google. So let's take a mini break from soldering. So this stream, if you're not familiar with how I do these sort of retro assembling, usually the first stream I get started with soldering things. So I have the real-time clock board as well. So that's what this is. Oh, I mentioned that I was going to talk about all the things. So maybe we should do that first. But I want to talk about the parts needed for the OPL2 card as well, because I do have those on me. Not like literally, but I bought them. So here's the OPL chips. I just want to find out a little bit more info if I can about the two chips there. So, but before we do that, I'm going to sit down. I'm going to turn my overhead light on. I'm going to turn my air conditioner on. And we're going to sit down, and I'm going to lower my desk. Let's talk about the project, or the different boards that I've got. Okay, so obviously I started working on the video card first. So this is a VGA video card, which is sort of weird because VGA, it wasn't until really 16-bit architecture, which is, if you don't know the difference, which I think ISA really is the 16-bit bus. The 8-bit bus I don't think is called ISA yet, but you know, it uses the same type of cartridge slot edge. So this down here is 16-bit when it has 2 bits. When it has 3 bits, when it has an extra card slot over here or an extra slot down here, that's VLB for when you get into 486. Pretty much only 486 platforms use that, I think. But that was what, 32-bit? So that was right before PCI came out. So this is a VGA card as well, but this is also, so it has the capability of outputting to a VGA port, but it only needs 8 bits to communicate with the CPU, whereas some of these, you know, they use 16. Actually, here's another Trident card that doesn't work. that is also 16. Also, I guess 16. This is a floppy drive controller and an IDE controller that also doesn't work, but it also is 16-bit. So when you get into 286 PCs, so really, in my opinion, the difference between the 8088 and the 286, or like the IBM XT and the AT, is the ability to get faster read-write to your peripherals, right? So you can actually get IDE, faster speed with an IDE controller versus the 8-bit stuff. So that came with AT stuff. So we don't have to worry about that right now, but it is an interesting next leap, into the AT style and 286. But okay, so this, I'm not really going to explain. This is how the computer is going to be outputting VGA. So it's got a video output. So it's got a VGA port that's going to go over there. So that's that thing. Next is the OPL2 card. This is the sound card, and OPL2, I guess, is the name of the chipset for Adlib. So it's like Adlib is like, is Adlib like the name brand OPL2, right? Like Kleenex to tissue. So let's look, OPL2, because I don't know that much about the technical. Oh, here's a Hackaday article. Is this gonna be good? Yeah. Oh, wait, recreating the sounds of the 90s synth. Nope. Is there like a, oh yeah, the Yamaha OPL. Okay, where's OPL2? Okay, so OPL is just the YM. So I'm gonna open up my parts. I just want to know, get more personal knowledge about what these parts are. The best of my knowledge, there is not a 8-bit VGA cards. Yeah. So 8-bit would have been either CGA or EGA. So CGA is actually a IBM standard. So computer graphics adapter was their first color video output. So just for simplicity, these VGA cards you skip all the CGA. CGA has a different connector, and it's actually a different style of video output, right? So CGA is more like it's more digital than analog, I guess, in the sense that with analog you have a spectrum of voltages, right, that adjust the amount of color, whereas CGA, it's on or off for each color at a time. So CGA had very basic number of colors, very like 8 or 16 colors or something, but that was just the first color graphics that were out. When you get into EGA and then VGA eventually, it just makes your life a little bit easier, because I think that VGA is backwards compatible, I think, right? So if you try to play software that was only for CGA, I think you could run it through a VGA adapter. The CGA is really more so if you have an actual CGA monitor, because you had to have a CGA or EGA monitor because the connector was physically different. So just for simplicity with modern devices being able to display, having a VGA card for this is nice. Yeah. This is why you're putting those chips on an 8-bit card. It will fit in the micro 88. Yep. Adlib was a company that took Yamaha's OPL chip and built a PC sound card around it, basically as is. Okay. FM. Okay, so yeah. So is that the chip that I've got here? But so when somebody says it's Adlib compatible, does that always mean it's OPL2? And if something is OPL2, does that always mean it's IPL or Adlib compatible? Look at these suckers. These things are beat to hell. So I got these a long time ago, or a couple of months ago. This one looks good though. So this is part of the OPL2 chip. What is it? This is a YM3812. So we didn't get this. So OPL1 is the YM3526, which is a single chip synthesizer chip, versus OPL2 uses 2 different chips, right? Oh, wait, did we skip it? Oh, here it is. created the YM3812. So this is the 3812 chip, right? So this is it's backwards compatible with the OPL1. But another related, what is this other little guy? So I have these other little guys here too. Big day Tuesday. We closed our house. Nice. That's cool. Finally done renting. Hey, congratulations. Welcome to endless home BS. But you know it's funny today. I actually, I'm a little bit handy, right? And about maybe it's probably almost a year now. We had a pipe. We had a pipe above our downstairs bathroom leak water onto the ceiling of the downstairs bathroom, and it turns out that the leak was actually from a different part. But they cut when the plumbers came to fix it. They cut a hole in that roof, in that ceiling, the ceiling of the downstairs that the water was leaking into. But they didn't find the leak. They found it in a different spot. But now I've got a hole. I had a little hole cut in the ceiling of my bathroom. My house is from 1953, and it has plaster, and not just lath and plaster, but it was like a metal lath because it was like a more advanced plaster. It's very dense, very hard. It's super annoying. So I figured, okay, I'll give it a shot. I'll give a shot of just replacing the sheetrock, like replace the ceiling with sheetrock. So that's what I started working on today. I have a multi-tool, an oscillating multi-tool, and I thought I could cut. I got a bunch of PPE. I have a 3M face mask. I had safety goggles on. I bought one of those disposable coveralls that you can throw away after you're done. So I have all this gear. I got a window, a box fan blowing out of my house to create negative pressure so I don't get dust in the rest of my house. And I put up plastic sheets to block the doorway. Turn the power off, and I took down the light fixture or whatever. Start cutting it. Somebody before must have replaced a section of that because there was some plywood. Now, what's weird is the plaster was about an inch thick. So from the lath to the actual finished surface is like almost an inch. But you could see where somebody tried to use drywall, but it wasn't, because drywall is only like half an inch. Like maybe you can get the half inch is thick. I think it's normally like 5/8 or something. So they used the piece of plywood, a couple of pieces of plywood, to make like a strapping, like a buffer that eat up some of that space so that it would be level with the actual ceiling that was there. And so that part actually came out easy. So I wanted to go back all the way to the stud so that I could have an easy job of just putting a new piece of sheetrock in and just taping it and calling it a day. But that metal lath is actually it eats through the multi-tool tool, the cutting edge of the tool. So I'm like, okay, I had to take a break. I had to figure out how to cut through plaster with metal lath. Somebody had a YouTube video where they used a multi-tool grout bit to actually cut just the plaster, because plaster is pretty hard. So they cut the plaster up to the metal basically with this grout bit, and then they used a specific metal cutting blade, like not an all-purpose blade, but like a metal specific blade to cut the metal. So I'm like, okay, shit. So I ran out to Harbor Freight. I took all my stuff off. I ran out to Harbor Freight, got both of those blades, and it went, it was still hard work, but it was way easier. So now I've got half of it done. I need to wait for some more bits because it ate through those bits too, but at least it was easier than what I was doing before. But then I have to put more sheetrock back up. So yeah, that's part 2 of that story will come eventually. Okay. This old house, yeah. Can't think of any PC cards that had an OPL2 chip that wasn't on the Adlib ports. CGA or EGA means no more magenta on my screen. Yeah, pretty much. Okay, so what is this other chip? So this is the OPL2 chip, but what is this little guy? So this is the Y3014B. What does this do? Is this part of the chip? Oh yeah, look. YM3812, which is the big guy. Oh, sorry, I'm reading the Wikipedia article again. YM3812 is used with YM3014B external DAC chip. So this is the DAC to output its audio in analog form. Okay, interesting. So this is the DAC that belongs with the OPL2. That's interesting. So I never really knew. I knew that there was always two pieces to OPL2, but I didn't know why. So who would use the OPL2 without that little DAC? That's interesting. YM3438, aka OPN2C on the Sega Mega Drive. Oh, so that was the Mega Drive 2. Oh, so is the OPL2 chip the same, or one of the same chips that's on the Mega Drive? That's interesting. All right, back to what I was talking about. The three different projects. So that's the OPL2 card. So this is our audio card. So this will give us audio output. So this is for video, but this will be for audio. Then the last guy here is this RTC card. Now, IBM XTs and IBM PCs, the IBM AT actually does have this feature, but the original IBM XT does not have a real-time clock chip. So basically what that means is you power off the system, you have to type in, if you install Windows or DOS, you would have to type the date in every time that you turn the computer back on. Versus having a real-time clock. Actually, you could use this card to add a real-time clock to an IBM PC. This will give us that functionality on our. So this is a pretty simple card. It's really, I think it's just some kind of a ROM or some kind of a chip that has built-in real-time clock functionality and a battery. So I'm just kind of sharing all this stuff because between now and the next stream, I'll have populated, I hope, or at least the next stream that I do this project, I'll have populated all these things. Because I hope I might not get all the pieces back in time. Okay, let's grab our bag of stuff. Let's try to find some VGA parts. So thankfully I had all the parts labeled with what they are, but unfortunately that means we have to dig for, oh, here we go. So this is U2. Oh, it's a socket. Now my brain needs this real-time clock card. Yeah, pretty much. Yeah, that's funny. Okay, so I'm gonna try to pull out all the pieces that go with this project, this card, specific card. Nope, that's real-time clock. OPL2. Sorry, I'm just like digging around in here. Maybe I'll switch to the face cam. Got my sack here. Okay, I got a just more sockets. Great. There's a bunch of sockets with this project. What's this? Oh, VGA U2. Well, actually, so I need to take all the chips. So all the sockets and chips I'm putting aside. So like these are all gonna go. They belong to this card, but they're not. I'm not putting them on yet. Real-time clock. OPL2. OPL2. Whoa! Look at these retro stickers. Fragile. VGA. Woo! I'll get some ferrite beads. Okay, we have a thing that we can solder. This card designed around surface mount components. I find it to be great for beginners because SMD components are a pain to handle for some. Which card? These cards are all through hole. The only thing that was surface mount was the VGA chip, unfortunately. So actually, you know, that leads to an interesting point that there is an open possibility for somebody else to create a nano 8088, right? If you took all the cards, and I think there actually might be like could you shove all these pieces onto one big card, or one, you know, make it even more compact somehow, like make a different, instead of using the ISA bus, you could have some other kind of bus, some other like little micro bus. That's funny. That has SMD. Yeah, through hole. Yeah, true. That is one of the reasons I do like this project is very. you know, it's more similar to the style of the original components, right? And like you said, not everybody wants surface mount things, or you know, and this computer is pretty small as it is, right? So it's not really, it doesn't take up that much room. Yeah. Okay, so we have these ferrite beads. Now, where do they need to go? Okay, so this is for, oh, I could switch back to my, I'm going to switch back to my chisel tip, my normal tip that I use. We're done with the, okay, so this is for ferrite bead 1 through 6. Which is all up in here. So I have ferrite bead 1, ferrite bead 6, ferrite bead 4, ferrite bead 3. Okay, so they're all in here. Cool. I need to 3D print that that bender tool, the through-hole component bender that makes the angles better. Okay, so where's 1? Ferrite bead 1, okay. Oh, I think this might be a problem. See, unfortunately, oh, maybe not. Maybe we're fine. Sometimes Sergey actually has the spacing kind of weird on these components. Okay, so, but this one seems to fit fine. Okay, so these ferrite beads, I don't think they have a direction, correct? I think we just send them. So let's actually put all 6 of them on before we solder. So where's ferrite bead 2 here? Filter. I like the look of ferrite beads. They're pretty cool. I mean, I guess I like resistors and stuff too, but I also like inductors too. Inductors are cool. Man, electronics is just cool to look at. What am I talking about? Pretty neat, getting there. So that's 3 of 6. Okay, ferrite bead 4 is up here. I can still stare at a board forever looking at the components. Yeah, seriously. You know what's weird though? When I was young, I had a phobia, a mild phobia, because I didn't like do this often. But sometimes I would go to my father used to have a machine shop, and like I said, this was in the 90s, so they had 80s stuff and 90s stuff. There was a board somewhere that had some of the, are they tantalums, I guess, like these capacitors, the yellow ones, right? So there was a board that had a bunch of these kind of older style caps like that. I was afraid of those. I thought they were very strange, and I didn't like looking at them. So I was kind of afraid of looking at those. Now I think they're pretty cool, but I did not like them when I was younger. I don't know why. Yeah, I have sort of a weird history with computers. Just having a computer doesn't necessarily mean that you're going to be interested in computers. You guys know that now. Like, does having a cell phone mean that you're going to be a programmer? No. It's the same with having a computer. At least when I had my Pentium, right? And maybe if I had it, maybe if our first computer was a Commodore or something, it would have been different. But it wasn't until, so just, you know, I was just an average computer user when I was young. It wasn't until my dad's friend Jim, unfortunately he passed away a year, was it more than a year ago? I'm not sure. My dad's friend tried to get my brother into computers, right? So he took my brother to a computer fair. So this is back when the best way to get computer deals for a custom computer was to, maybe I think it's a mushroom. Yeah, maybe. The best way to get computer deals was to go to a computer convention and buy the parts there. And I was not old enough to go yet, or I don't know, maybe he didn't think that I was going to be interested or something. Anyways, my brother was a little bit older than me, and he thought my brother would be interested in going to the computer fair and building a computer. So he took him along. This was probably Windows XP era, so early 2000. So he took my brother, and they, you know, eventually they built a computer together. But I think his intention was to teach my brother, to have him be more interested in computers, like actually help him build it, install the operating system and stuff. But little did he know that I wanted to do it. I wanted to, you know, maybe not until I knew what was happening. But when they came home with all the parts and they were building the computer, I knew right away I wanted to do that. Not like for the rest of my life, but I was like, maybe it was like a mixture of jealousy. I don't know. Something about that moment of like, my brother gets a computer and I don't. Like, just a lot of things happen, right? Like me understanding that custom computers were a thing. Going from, a computer is sort of like one per family to, you know, every person can have their own computer. And not only that, but like they can choose the parts that are in it. And the parts are different. Like the parts are not like all the same. That sort of blew my mind. And so it wasn't, you know, I didn't get to build a computer until later. But actually the first computer that was technically mine, like my own, my sister worked at Pizza Hut, a local Pizza Hut, and she had a friend that built computers as a side hustle. And so he built me my first computer. But then the first thing that I did, eventually I upgraded the graphics card, and that was the first thing that I did to my own computer. That started it, and then from there, you know, the next computer that I built, and from then on, I built my own computer since then. So in a way, my dad's friend building a computer for my brother made me want to build my own computer and got me started with computers. And eventually, you know, it's my career now. I'm a software developer, so I don't think he put that much, you know, I don't know, not sure. Hey, Gary T. So I don't know if you guys can relate to that story at all, but that's how I started with computers. And then, yeah, from then on, I've been super interested in pretty much any aspect of computing. I mean, maybe I don't know enough to be an expert in everything, but yeah, I guess that's why I'm excited about technology and stuff ever since then. Big change from one computer per university to one for your wrist. Yeah, one in your pocket, one in your desk. Yeah, exactly. Not only that, but like now it's like the opposite. Now we're going from one, you know, computer in every room, or like if you have a bunch of kids, like every kid might have a computer, to my sister, she has 2 kids and they don't have a computer in their entire house. They have cell phones, but they don't have a laptop even. They have an iPad and phones. They don't have computers. Not a single computer in the whole house. So I don't know. We used to be a proper society. So it was a lot, you know. It went from it being a special thing, you know, maybe your town, nobody in your town had one yet. Oh, look at this big chunker VGA port, so that's coming. Maybe nobody in your town had their own PC yet, to, you know, a university nearby had one, and then you know, to everyone, one in your computer, one in your house, then I don't know. Just kind of crazy. Computers are dead. Gen Z don't like TVs or computers. Well, they like TV as far as watching YouTube or TikToks. They can care less about. I'm trying to get a box that I can start separating these things out because I can't sort them. Yeah, they could care less about cable. I don't have cable. My parents are the only ones in our whole extent. Actually, no, my sister has cable, but she's kind of she don't know what's going on. My sister's kind of not a Luddite, but she's just not with it. Just a different time. The time of the most interconnection between people ever in all of society, and it's not through a computer. I'm shocked. Okay, L2. Do we have some kind of a inductor? Okay, we've got an inductor. Ooh, look at this. It's fun. Whoa. I thought inductors were the windy boys. This is not a windy boy. Okay, well, I don't know if it has a direction. Okay, so this is for L2, which is down here. 2.7 microhenries. That's pretty fun to say. Okay, let's put our microhenries down here. Don't have to worry about soldering that guy yet. All right, what else can we find? Gotta sort all these boxes, all these things. Yep, I guess that's why one reason I'm so nostalgic is because, and not just for things that I grew up with, but for things I didn't grow up with, right? Like IBM stuff. I just like preserving it all, and then maybe one day my son will be interested and I'll be able to teach him all this stuff. Probably not, but just interesting. I hook up a computer to a TV at living room and using computer while on the couch. Yeah, you hardly touch your cell phone once you're back home. Yeah, pretty much. Me too. Yeah. Well, I'm so addicted to Twitter that like I'll take a break from using my computer to use my other computer, my cell phone. Yeah. I don't know what it is about having a computer. It's so huge, and like I understand that it's like an inefficient use of space when that you can pretty much do most of the things that you need to do on a phone. Like instead of a huge box. Okay, so we have some more here's L1 and L3, so here's more inductors. These are 5.6 microhenries. Okay, so L1 is up here. All right, and then I think I saw L3 over here. Yes, I did. Okay, let's solder these. Yeah, I have sockets for all the chips. Yep. Including the RAM. I don't know why, but, well, I guess the RAM probably makes the most sense, right? In case I get a bad RAM chip. But I don't think I have a problem. I'll have a problem with any of the other dip packages. But You never know. Worst case scenario, I could always desolder them, but, you know, I have them anyway, so whatever. I want this solder. There we go. Is this dark a little bit? Is that a little brighter? Cool. So far, I like these Nipex or Knipex, whatever. Side cutters. I've been using them for a while, and they're still pretty sharp. So I guess I recommend them if you're interested in buying them. Okay, let's find some more goodies. Oh, okay, we got a capacitor. And some resistors. And oh man, look at that thing. Dang, you got the potentiometer for the volume. That's cool. Put that over there. It's a big boy. And some more resistors. Okay, so we got a bunch of resistors we can solder on. Yeah. Yeah, I've been using just the red ones that are labeled as Hako, but on Amazon, but eventually they wear out. The cutting blades wear out, so I figured I would try these because these get pretty good reviews. I'm sure if I zoomed in with my microscope, I could probably find some cuts in them, but so far they're still pretty sharp. Okay, let's put this little capacitor on. So this is C19. Okay, do we see C19, C21, C22, C15, C9, oh, C19, 100 puff. Woot. Okay, goodbye, C19. Okay, so now we have a bunch of resistors. So this is R1 through R8. Okay. I'm gonna guess that they're all over here. Yep. Oh, and I think these are too big. Oh wait, some of them are not. Oh, never mind. Okay, no, they're thicker. Okay, so where's R1? Okay, we'll find them. Oh, over here. Okay. That Nipex is $35 USD. Was it? I could have sworn it was a little less than that. Let me see. Oh yeah, I guess you're right. $27. Yep, guess close to that. I was just I don't know. I was fed up with the cheaper ones that I'm like, whatever. If they last a while, here's the model number 7803125. If they last longer, then it's worth it. Okay, R1 is over here. Yeah, I need to get a better soundtrack because the songs repeat. Oh, yeah. So I think the footprint for these resistors is not correct. So I end up doing this. You guys have probably seen me do this. I end up just dangling them, you know, doing them angled like that. So that's just how it's going to be on this board too. That's R1. So where's R2? D2. Ha ha ha. R2's up here. This one almost goes flat. Almost. So where's R3? Oh, down here. Down there. Just bend your leads tighter. Yeah, probably, but I don't think they're supposed to be bent that tight. You're probably right. Here, maybe if I had my, where are they? My needle nose pliers, I could do that. All right, let's try it. This is R3. Oh no! Yeah, I mean, kinda. Doesn't sit quite flush. Yeah, I don't like it. I'm gonna dangle it. Gosh, I better stop messing with it because I'm gonna ruin it. Okay, sorry, that one was goofy. Okay, R4. Yeah, I need to get those lead bender thingies. Yep. I gotta print one. Just been lazy. Were those supposed to be 1/8 watt? Maybe. We can look at the BOM. Let's look at the BOM for Super VGA. R1 through R8, 1/4 watt, it says. So, no. Okay. What do we have? That was 4. So now where's 5? R5, where are you? Oh, down here. Okay, now we have R6, which is up here. And then R7 and R8. Well, those ones are kind of fugly, but that's all right. Variety is the spice of life. Okay, cool. Let's solder these. So I'm excited to get the controller lag tester thing set up for Mister. I think that's kind of a tool that I probably needed if I'm going to be, reviewing controllers and adapters and things. I've never really felt compulsed to get one, but like I said earlier, I'm gonna start switching to making videos instead of streaming again. And if I'm gonna recommend stuff, I need to know the lag. So parts wise is not bad, but the part that kind of it's not scary. I can figure it out. You have to solder wires to the any controller that you want to test. So like I'll have to open my series controller, Xbox Series controller, and solder wires in it. I have an original Xbox controller. I got to solder wires in it. I have that the Brawler Retro Fighters Hunter controller. I have to solder wires in. So anything that you want to do the latency of, gotta get some wires. But yeah, still. How we doing? Nice. Nice resistors. Okay, on to the next bag of resistors. This is R7 through R13. So this might actually be the rest of the resistors for this whole board. Oh no, I see. Nope. I still see R14, 15, and 16. So there's 3 more. Okay, so this is R7, which is... I see R9 down here. Oh, is R9? Huh. Wait a minute. Oh, never mind. I have the wrong bag. This is for the OPL2 project. Whoops. Got ahead of myself. Okay, back into my bag of goodies. That's for OPL2. Real-time clock. Oh, here's a resistor. OPL2. Ooh, the clock crystal. That's fun. OPL2. RTC. OPL2 capacitors. OPL2 resistor. Cap. Oops, there's some resistors. Oh, look at that cool little clock thing there. Can't really see it because it's very shiny. Crystal. Tiny crystal. OPL2. Oh, here's some resistors. OPL2. Ooh, another capacitor. OPL2. OPL2. Oh, here's a resistor. What's that clock? OPL2. OPL2. Okay. All right, I'm at the end of my bag, but I do know that there are more things coming for this board. Sometime, the memory at least, and some other stuff from Mauser. So there's a couple of things we could do, a couple more of these tonight, but between now and next time that I stream the computer stuff, I'm gonna populate all the boards. Well, except for the chips. We'll leave the chips out because I usually like to talk about what they are, but I'll put the sockets in. So that goes for this card and the sound card and the real-time clock. Okay, R9. Where's R9? Oh, here it is. 1K. Now this is a small one. This looks like it would fit. I gotta print one of those lead bender things. There we go. Snug as a bug. Got a capacitor. Let's see, can we do these big resistors maybe? Okay, so this is R10 through 13. Oh, okay, it looks like it's the rest of the resistors on this line here. Okay, I think this is the last. Actually, I kind of want to put the VGA. Kind of put the VGA connector in, and the knob, the potentiometer. Maybe that's the last thing I'll do. All right, that's that. I want to solder on the VGA. Oh, the knob is for the other project. I don't know why I had that over here. Huh. That's for the OPL2. This has a VGA port. Let's solder the VGA port on, just to make it official. Look at this ridiculous container they sent me. Just one of these things in it. That's kind of a cool bin, I'm not gonna lie. Maybe like screws or something. Kind of cool. All right, so this goes in the top, I believe, like this. Okay. Cool. Okay, so we got the ground pins. Hey, nice. All right, now it's a VGA card. That's funny. Cool. All right, so I think that's what I'm going to call it tonight. I do need to, there's a bunch of other stuff, obviously, for this board and the other two boards to solder, to populate. So I'm going to do that. And then next stream, next PC stream, we're going to be putting all the chips on each card, and they probably each have their own firmware that needs to get flashed. So we'll flash those with the flasher and put them on there, and then we'll test. And then hopefully, fingers crossed, by the end of that stream, I'll have a working DOS installed too, because I don't think I got DOS installed. Maybe that might be its own dedicated stream, actually getting Windows. Well, actually, I said I was going to do a stream on how to use XTCF, that firmware too, and install it, because that's kind of a pain if you've never used XTCF. It's not just flash a BIOS and run it. You have to do it. You have to flash the BIOS on a computer while using a computer. Thanks, Ian, Scott. You always show up for all these retro PC streams, and I love it. I appreciate it. Thanks also to PCBWay for sponsoring this video. Without them, this whole build wouldn't be possible. And yeah, pretty much without them, we wouldn't be able to be building this PC. So, all right. Thanks, everybody. We'll see you on Wednesday. Wednesday. See you later.